look at this. The God particle. What's the God particle? So, do you want to know about the God particle? Let's see this video.
Welcome to this video about the God particle, also known as the Higgs boson. In this video, we'll dig deeper into the background meaning and implication of discovering the God particle. Why is it called the God particle? The Higgs particle is called the God particle because, like God, it is very powerful everywhere but hard to find. The fact is that the origin of the name is not so poetic. The name comes from a book by physicist Len Lederman, which, while still in the draft form, called The Goddamn Particle, to describe how difficult it was to find the Higgs particle. The title was later edited by the book's publisher, fearing that the meaning was too harsh. Why is it called the Higgs boson? Higgs is evidently named after Peter Higgs, now 83 years old, who first proposed the theory of the invisible field and the God particle. While bosons are non-object particles that work as force chambers or messengers that move between objects particles, the interactions of matter and non-material particles produces three main forces: the strong, weak, and electromagnetic force. There is a fourth force, namely the gravitational force. The force of gravity is a mystery in itself because until now the trigger is still being sought and is suspected to be caused by a boson called a graviton. The God particle was first predicted in 1964 by the physicist Peter Higgs, who proposed that there is a field that permeates the universe, interacting with the particles and giving them mass. The Higgs theory is part of the standard model of particle physics, which describes the fundamental particles that make up the universe and the force that govern them. Its story is more than 50 years ago. Physicist Peter Higgs and five colleagues proposed the theory of an invisible field that runs throughout the universe and gives mass to particles, makes them coalesce, and begins to form stars and planets. According to a theory proposed in 1964 by the Higgs field, it interacts with tiny particles to form atoms, giving them mass so they don't travel through space at the speed of light. Higgs particle, that's the field, actually has a signature particle. If you manage to find the particle, then the existence of the field can be proven. But in the next half century, no one could prove the existence of the field that was later called the Higgs field, until scientists at the European Agency for Nuclear Research, or CERN, announced their findings. In 2012, to find the God particle and determine its character, scientists conduct experiments and research by breaking up protons in the Large Hadron Collider, or LHC, a particle colliding machine that operates at nearly the speed of light and is located on the border of Switzerland and France, announced the discovery of the Higgs boson, confirmed the existence of the Higgs field, and provides strong evidence for the standard model.
The discovery of the God particle was the result of years of collaboration between thousands of scientists from around the world who worked together to design and build the LHC, the world's most powerful particle accelerator. The God particle was not detected immediately, but was discovered through data analysis and the detection of other particles, resulting in particle collision at the LHC. Scientists use mathematical and statistical methods to identify signs of the existence of this particle. The LHC consists of a 27-kilometer long circular tunnel where protons are accelerated to near the speed of light and then collide with each other. releasing a shower of subatomic particles, including the elusive Higgs boson. How was the particle found? With the splitting of proton at the LHC, experts will try to find the so-called good particle or Higgs boson from the bits or proton broken off in the machine built by the European Nuclear Research Agency or CERN. The collision that occurred in the machine produced temperatures that are 100,000 times hotter than the sun, repeating what happened during the Big Bang, which is thought to have taken place 14 billion years ago. The discovery of the good particle was a significant breakthrough in particle physics, providing evidence of the Standard Model and answering of the most fundamental question in physics: how do particles acquire mass? The good particle providing an explanation for why other particles have mass. Prior to the discovery of this particle, the standard theory of particle physics could not explain why some particles have mass and others do not. Good particles interact with the Higgs field, which pervades all of space. Other particles interacting with these fields gain mass. Without the Higgs fields, the particle will travel off at the speed of light and will have no mass. The Higgs field is an invisible field that fills the universe, giving particles their mass by interacting with them. Without the Higgs field, particles will move at the speed of light, making the formation of atoms and molecules impossible. The discovery of the good particle has opened up new avenues for research and innovation, including the development of new technology, materials, and applications. The discovery of the good particle confirmed the Standard Model of particle physics, which has long been the basis for explaining particle phenomena. However, there are still many open questions and challenges in achieving a deeper understanding of the nature of these particles and basic physics.
However, the discovery of the God particle also raises new questions and challenges for physicists, such as the nature of dark matter and dark energy, which make up 95% of the universe and have yet to be detected. The implications of the God particle extend beyond the realm of physics, with potential applications in fields such as medicine, energy, and environmental science. Mass of the God particle. The mass of the God particle is about 125 gigaelectronvolt GeV. This makes it a relatively light mass particle within the standard framework of particle physics. Short life. God particles have a very short lifetime. Once generated in a particle accelerator such as the LHC, it dissipates into other particles in less than 1 septillion seconds, 10 to the power of 224 seconds. Important for cosmology. The God particle also has implications in cosmology. Its presence in the Standard Model of particle physics helps explain the formation of the structure of the universe and why the universe has the mass it does today. No energy economy. Production of God particle in a laboratory like the LHC requires very high energy. Therefore, it is difficult to practically produce this particle on a large scale. In conclusion, the discovery of the God particle is a major achievement in the field of particle physics, confirming the existence of the Higgs field and providing evidence for the Standard Model. These discoveries have opened new avenues for research and innovation, and have the potential to impact society in a number of ways.
We hope you enjoyed watching this video. Thank you all.
Bye-bye!
Bye.